We know now that the estimate is too large, so we'll use the percent error formula to find out exactly how much, what percent too large. So we'll replace the approximate, which was the 52 units squared, and what we know is that it actually is 16 pi units squared. So we'll substitute that in. Absolute value is a grouping symbol, which means it gets dealt with at the end. So we won't be taking the absolute value yet. We'll be doing that as we move through the problem. We probably will do our best work if we recalculate that 16 pi, and we found that it was approximately equal to a 50.3. So that's what I'm going to use just for the sake of being able to do calculations. So we'll leave that here in the denominator, and what we need to do is do the calculation 52 minus 50.3 before we take the absolute value. That gives us 1.7, and we have that inside the absolute value. And now we can actually start to calculate these absolute values. So the absolute value 1.7, the distance from 0 to number line, well, 1.7 is 1.7 units away. And 50.3 is 50.3 units away. We're multiplying by 100 because ultimately we want a percent. And that's how we calculate, turn it from its decimal form into a percent. Because we're approximating with pi, and doing some other approximations within this, we might not get all exactly the same answer. If you stick with pi and you do your division and then you multiply by 100, you would get 3.45%. When I calculate it using 50.3, I get 3.38%. So you have a little bit of variation in your answer just based on whether you're using pi, whether your calculator uses pi, how many decimal places you go with. So you should be somewhere around 3.45%. I'll know it's a percent because I multiply by 100, which allows me to turn it into its percent form from the decimal form. So this is the percent error and between the amount that he calculated in his estimate and the actual amount that we can calculate using the formula.